All right, so we have talked about the shape of a frustum, but now we're going to find the surface area and volume of a frustum. Now, a frustum is part of a cone. So let's actually draw in the other part of this cone. I'm going to draw it with a dotted line because it doesn't actually exist. But here's that top of that cone. So to find the surface area, we have a large cone that we can find the surface area of. But on that large cone, we would need to subtract this top cone, just the lateral area, and then we would need to add on this surface here, the base of the small cone. Okay, so that is our process of what we're going to be doing. So we're going to be taking the surface area of the large cone. We are going to subtract the lateral area of the small cone. And then we're going to add the area of the small base. Okay, so let's get started. We have the small base radius is 6 units. The large base radius is 10. And the slant height of the frustum, not of the cone, just this part here, is 14. Okay. So before we begin with the surface area, let's find the height of the small cone, the large cone, and let's find the slant height of this large cone. So I'm going to label this slant height here, x, of the small cone. And we're dealing with similar triangles here. These are both right triangles. They both share the same angle up on top. So by AA, these are similar triangles, so we can set up a similar triangle ratio. So if I do x, the slant height of the small cone, over x plus 14, which is the slant height of the large cone, that would be equal to the small cone's radius and over the large cone's radius. So now cross multiplying here, I get a 10x is equal to a 6x plus 84. Subtracting that 6x over, I get a 4x is equal to an 84. Dividing by 4, x comes out to be 21. So that 21 is the slant height of the small cone, and so the slant height of the whole thing, 21 plus a 14, is a 35. We'll find the actual height actually when we do volume. So let's actually do the surface area now. So the surface area of the large cone is going to be pi times 10 squared. And sorry, let me say that this is surface area. So pi times 10 squared plus pi times 10 times the radius, times the slant height of the whole thing, which is 35. And then I'm going to subtract the lateral area of the small cone, which is pi times 6 times the slant height of that small cone, which is 21. And then I'm going to add on the area of the small base, which would be pi times 6 squared. So when I calculate this all together, a 10 squared plus a 10 times 35 minus a 6 times 21 plus a 6 squared, I get 360 pi. This would be exact, and that's exactly what they wanted you to do. Units squared. Okay, so now to find the volume, we are going to need the heights of the small and the large cone, and how we do that is we do the Pythagorean theorem. So I'm going to make y the height of my small cone. So if I do a y squared plus a 6 squared, that equals a 21 squared. So a 21 squared minus a 6 squared, y squared equals a 405. And if I take the square root of both sides, I want the exact volume, so I need to put it in simplest radical form. 405 can be split up into an 81 times a 5, which means y is going to be a 9 root 5. So that is the small cone's height. Now the large cone height, I'm going to label as h. And so if I do the Pythagorean theorem there, an h squared plus a 10 squared, that would equal a 35 squared. So if I do a 35 squared minus a 10 squared, I get h squared is equal to a 1,125. Putting this in simplest radical form, 1,125 can be split up into a 225 times a 5, which means h would be equal to 15 root 5. So now, completing the volume. If I take the volume of the large cone minus the volume of the small cone, that would give me the volume of the whole thing. So the volume of my large cone would be 1/3 pi times 10 squared times 15 root 5, because that's the height of the large cone. And I'm going to subtract the volume of the small cone, which is 1/3 pi 6 squared times 9 root 5. So a 10 squared times a 15 times a 1/3 is a 500, and then I would just tack on the pi root 5. And I'm going to subtract a 1/3 times a 6 squared times a 9 is a 108, and then I tack on the pi root 5. And since both of these have a pi root 5, we can actually combine the 500 and the 108 to get a 392 pi root 5 units cubed. And that is an exact format, which is what they asked to do. All right, moving on to the next problem. Okay, so the surface area of the prism, we're actually just going to be finding the of the pyramid. We're just going to find the lateral area of the pyramid, and then we're going to find the lateral area of the prism and one of the bases. This is a hexagonal prism and pyramid, so we do need to find the apothem. And so this apothem splits this side into 6 here. We should recall that a hexagon has 120 degree angles, which means this splits into a 60 degree angle here, and this is a 30. So going from the side across from the 30 degree angle to the side across from the 60 degree angle, we multiply by root 3. So 6 root 3 is my apothem. All right, so going from there, the surface area of the pyramid would be, again, we're just doing the lateral area of that pyramid, 1/2 times the slant height times the perimeter. So it's 6 sides of 12, so the perimeter is 72. So I have a 72 times a 14 divided by 2. I have 504 as the lateral area of that pyramid. I'm going to be adding that to the surface area of the prism. which instead of doing 2 times the area of the base, we are just going to do 1 area of the base. The base is a hexagon, so it will be 1/2 times the apothem of 6 root 3 times the perimeter of 72. And then I would add on my height of my prism, which is 18, times the perimeter of the base, which is 72. So a 72 times a 6 times a 1/2 gives me a 216 root 3 plus 18 times a 72, which is a 1,296. Oops. We add those two surface areas together. I can only add the 504 and the 1,296 together, and that's an 1,800. And then I just leave the 216 root 3 on the very end. This would be exact form. So that's our surface area. Now our volume. I'm going to do the volume of the pyramid and the prism separately. Okay, so the volume of the pyramid is going to be 1/3 times the area of the base, which the base is the same as the base of the prism. So 1/2 times the apothem times the perimeter. But then we need to multiply the height in. We don't know the height. So we're actually going to take the apothem, which is that 6 root 3, and the 14, and we're going to find the height of this pyramid. So h squared plus 6 root 3 squared is equal to 14 squared. Now when I do a 6 root 3 squared, I do a 6 squared, which is a 36, times a root 3 squared, which is just a 3, and so I get 108. 14 squared is a 196. Subtracting that 108 over, I get h squared is equal to 88. Taking the square root of both sides, 88 can be split up into a 4 times a 22. So that means h in simplest radical form is 2 root 22. And it's going to be multiplied into my pyramid volume. Okay, so I'm going to do a 6 times a 72 times a 2 times a 1/2 times a 1/3, and I get 144. And then I do a root 3 times a root 22, which gets me a root 66, and that cannot be simplified. So that's the volume of the pyramid. Now I'm going to do the volume of the prism, which the volume of the prism is going to be the area of the base, so 1/2 apothem times perimeter, and then times the height of that prism, which is 18. So I do an 18 times a 72 times a 6 times a 1/2, and I get a 3,888, and then I just tack on that root 3. And so now I'm adding these two volumes together to get the total volume, which I just leave as a 144 root 66 plus a 3,888 root 3. I cannot combine those together because they do not have the same exact radicals. So I just leave it like so. All right, that brings us to the end of this lesson.